I am going to discuss merge sort in this video. Merge sort is a popular sorting algorithm which follows the divide and conquer approach. So basically it divides the input arrays into two halves, and then two halves in the sense two equal sub arrays. So whatever the example array is given, that would be divided into two equal sub arrays, and then it would sort each sub array independently and then merges them back together finally in a sorted manner. So this is how the merge sort algorithm works, and this is what the divide and conquer strategy does. So basically it follows the merge sort can be solved only using divide and conquer strategy only. So let's see how the merge sort actually works using divide and conquer approach. So the very first step is divide, which means here the input array is divided into two equal subarrays recursively until each subarray contains only one element in the list. So the list would get subdivided into two until there is only one element in the list. That is very first step, divide step. Once divided, the next step is going to be the conquer step. So in the conquer step, we are just going to recursively sort each and every subarrays. So this is what we do under the conquer step. Once the conquer step is over, the third step is going to be the merge step. Under the merge step, all the sorted subarrays are merged back together to form a single sorted array. So this is how the merge sort algorithm is going to work. So let's take one example. Let's have an unsorted array. So this is the example given here. If you look at the example here, it is unsorted array only, and also it has n elements. Here the n value is 4. So totally 4 elements are there in the array. So let's solve it using the divide and conquer strategy. So there are 4 elements in array. As I discussed earlier, like it is going to use the divide and conquer strategy. So the very first step is we are just going to keep on subdivide the array, subdivide the problem into two equal subproblems until there is only one element in an array. So if you check here, yeah, there are 4 elements in an array. So we are supposed to keep dividing the array until there is only one element in the list. So now when you divide, before you divide, we are supposed to identify the midpoint so that the array can be equally divided into two equal subarrays. So to identify the midpoint, the formula is low plus high divided by 2. So the very first index is going to be the low and the last index is going to be high, right? So 0 plus 3 by 2, the midpoint is going to be 1, which means till 1 it is going to be one sublist, one subarray, and all the remaining elements are going to be the another subarray. So we divide this array into two equal subarrays. So in the left subarray only there are 2 elements, and in the right subarray again there are only 2 elements. So until when we are supposed to divide, keep on dividing the subarray means until there is only one element in the subarray. So now the index of each element is, it is 0, 1 here and 2 and 3 here. Again identify the midpoint. If you identify the midpoint again, this would get divided into 2. So in this array there would be only 16 in the left subarray, and in the right subarray only 7 would be there. And then again if you divide this subarray, this is going to be the midpoint. So after dividing it, there would be only 5 in the array and 15 in the right subarray. So now the division part is completely over. So the division part is done here. The next step is conquer part. So until there is only one element in the list, we are supposed to divide it. Yes, we divided it. There is only one element in the subarray. Now the next step is conquer part. So how are we going to conquer it? How are we going to solve each and every subproblem now? It must be recursively sorted here at this step. So let's discuss how to recursively sort each and every subarray independently. So now the next step is conquering step. So recursively sorted. So now we are going to sort these two array now. So you are going to create one new array here, and then you are just going to compare each and every element in an array. For example, just imagine that this is going to be this is your new array which is called high, and this array is H array and this array is J array. So you are supposed to compare array of H with array of J. Whichever is lesser, we are supposed to keep that into the new array. For example, array of H is 16 and array of J is 7. So if array of H is lesser than array of J, we are supposed to write array of H inside the new array. If array of j is lesser than array of h, array of j we are supposed to write inside the new array. Now if you compare array of h and array of j, yes, array of j is lesser, so we are supposed to write array of j inside the new array. Array of j is 7. So once written 7, like we are supposed to increment our j pointer. Why? Because we wrote the value, new value from the j array only. So once written, we are supposed to increment the j pointer, but unfortunately there is no more element here over there in the j array, so the j value cannot be incremented, so it would end here, which means the j array is completely over. So once, like one subarray, in one subarray the elements are completely over, means you have to look at the opposite array, which is the left subarray. Whatever the elements are remaining, we are supposed to copy down in the new array in the same order. So if you look at the opposite array, in the left subarray there is only one element remaining, so you can just copy and paste it over, like you can just include it in the new array. So now after sorting these two arrays, right subarray and left subarray, we are getting one sorted list, that is the new array, in which there is 7 and 16, which is in the sorted order. And then again combine these two, like conquer these two and create one new array. Compare array of h as well as array of j, whichever is lesser we are supposed to write into the new array. The array name is I. Now compare array of h and j. Yes, array of h is lesser, so we are supposed to write array of h in the new array. Once written, we are supposed to increment the h pointer, but there are no more elements over here in the h array, so you just move on to the next array, the opposite array, which is there in the other side. So if there are any elements which are left unconsidered, we are supposed to copy it directly. We can copy it into the new array without changing the order. But if you check it out, like there is only one element in the opposite array, in the next array, so just directly you can copy it into the new array. 5 and 15. If you look at this array, yes, again this array is in the sorted order. Now again merge it back, like you just combine these two again, create again one new array called I. Now your left subarray is h and your right subarray is going to be j. Compare again array of h and j one by one. So when you compare array of h and j, yes, array of j is lesser, so we are supposed to write array of j into the new array. Once written, we are supposed to increment your j. Suppose if you had written h, means you are supposed to increment h. Since we have written j over here, we are incrementing the j to the next step. So now again compare array of h and array of j, 7 and 15. Array of h is lesser, so write array of h in the new array. Once written, increment the h pointer. Now h is pointing 16 and j is pointing 15. Now again compare array of h and array of j. Array of j is lesser, so write array of j inside the new array. Once written, increment the j pointer. There are no more elements to consider, so this array would stop till here. If you look at the another array, yes, there is one element is unconsidered, so you are supposed to copy the same over here in the new array. Now if you look at the array, yes, the array is sorted, because finally there is only one array, and this array is this array would be considered as the final sorted array. So if you check this array, yes, all the elements are sorted. So this is how the merge sort algorithm works. So let's discuss one more example. You will get more clarity now. Let us consider this 9, 5, 1, 20, 42, 19 and 6. So totally if you check, there are 7 elements are there. So there are 7 elements and these are the index values. So in the merge sort, the very first step is we are supposed to divide the list, right, into 2 equal subarrays, 2 equal sublist. So if you check, the midpoint is 0 plus 6 by 2, which is 3, which means till 3 it is going to be one subarray and rest are going to be there in the another subarray, right. So 9, 5, 1, 20. This is one subarray. And again 42, 19 and 6 would be there in another subarray. Again you just keep subdividing the list until there is only one element in the list. Then again if you divide it, 0 plus 3 by 2, the midpoint is going to be 1. So till 1 it is going to be the left subarray, and from 2 till 3 is going to be the another subarray, right subarray, 1 and 20. And then again 6 plus 4 by 2, the midpoint is going to be 5. So till 5, one subarray which is the left subarray, and 6 alone would be there in the right subarray. And then again, so until there is only one element in the list, we are supposed to divide it. So now if you check again, yes, there are 2 elements are there, again you just divide it. If you divide it, there would be only 9 in the left sublist and 5 in the right sublist. And then again here, if you divide it, 1 in the left sublist and 20 in the right sublist. And then again the left subarray, there would be 42, and here 19. If you check this, there is already only 1 in the array, so retain the same here. So now if you check, all the array contains only one element, right? So now once the division part is over, the next step is going to be the conquer step. So we are just going to start merging it and sorting each and every list independently. Now start merging these two. These, I'll change the color, these two, then again these two, and again these two must be sorted. So if you sort it, which means what? We are supposed to create one new array. After creating the new array, we are supposed to compare it, H and J. So left array is going to be H and right array is going to be J. Compare array of H and J. Array of J is greater, so I am writing array of J here. Then increment J. J cannot be incremented. If you look at the other side, there is only one element in the array, so you just copy the same into the new array. And then again, like we just merged these two arrays, move on to the next 2 arrays. Again this is H and this is going to be J. If you compare H and J, array of H is lesser, so write array of H and increment H. It is not possible because there are no more elements. And if you check the next array, there is only 20 inside the right subarray, just copy the same into the new array, 20. And then again merge these two, array of H and array of J. Array of J is lesser, so copy array of J inside the new array. Increment J, J cannot be incremented, so if you check the opposite array, there is only one element remaining, so copy the same. Directly it can be copied to the new array. And if you check the next array, there is only one array. Only 2 arrays can be merged. Since there is only one, we can retain the same here again. Inside the array, like there would be only 6. Again combine these two and these two. Create one new array. Compare array of H and array of J. When you compare array of H and array of J is lesser than array of H. So write array of H inside the new array and increment J. Compare again array of H and array of J. H is 5 and array of J is 20. So H is only lesser array of H. We have to copy array of H into the new array. Once written, we are supposed to increment H. Compare again array of H and array of J. Again array of H is lesser, so copy 9 inside and increment H. H cannot be incremented because there are no more elements in the left subarray. So move on to the right subarray. Yes, only one element is left unconsidered, so directly it can be copied into the new array. So now if you check this list, yes, each and every conquered array, if you check, it would be in the sorted order only. So after merging these two, we got one new array. If you check out this array, all the elements which are located here is in the sorted order only. And then again combine these two arrays. So create one new array, and the left subarray is H and right subarray is J. Compare array of H and array of J. Array of J is lesser, so copy array of J inside the new array. Try to increment J, but there are no more elements. J cannot be incremented. So if you check the other side, there are 2 elements remaining which are left unconsidered in the H array. So copy the same into the new array without changing its order. So if you check, 19 and 42 is there. So 19 and 42 needs to be copied here into the new array without changing its order. So 19 and 42, I just copied these 2 elements. Now if you check this subarray also, yes, it is in sorted order. This list also is in the sorted order. Again merge these 2. Until we got one final list, we are supposed to keep on merging it. So now create again one new array here. and the left subarray as usual it is going to be array of H, and the right subarray is going to be array of it's going to be the J array. So compare array of H and array of J. Array of H is lesser, copy array of H into the new array. Once written, increment H. So if you are writing value from H array means you are supposed to increment H pointer. Writing the value from J array means you are supposed to increment the J pointer. Since I have written it from the H array, I just copied the new value from the H array. I am incrementing the H over here. Again compare array of H and array of J. Array of H is lesser again, copy array of H into the new array, increment H again. Again array of H and array of J is lesser than array of H, so copy array of J here, which is 6. Once written, increment your J. Compare H and J again, array of H is lesser, copy array of H. Once written, you are supposed to increment H. Again array of H and J, if you compare, array of J is lesser than array of H, copy array of J inside and increment J. Again array of H and array of J, array of H is lesser, so copy array of H and then increment H. It can't be incremented because there are no more elements to consider in the left subarray. So move on to the right subarray and check if any of the elements are not considered. Yes, one element is left unconsidered, so copy the same here into the new array, which is 42. Now this is our final sorted array. If you check, yes, all the elements in the final array is sorted. So this is how the merge sort algorithm works: divide, conquer and merging you are performing here. So if you check here, see all these are divide step. So we keep dividing the list until there is only one element in the list. Once we reached one element in the list means we would start merging it. So here we are performing the merge step here. Here again merging. Again we are merging, performing the merging step over here. So this is how the merge sort algorithm works. So let me give one exercise problem. Please try this out. 10, 15, 6, 4, 9 and 7. Please try this out. Thank you.